definition of gamma function. So we can write it as gamma n plus 1 equal to integral 0 to infinity e power minus x into x power n into dx, where n is greater than 0. Now we write the question: evaluate integral 0 to infinity e power minus x into x power 4 into dx. So here, by using the definition of gamma function, we compare x power n. So here n equal to 4, n equal to 4, but here we substitute in definition, substitute n equal to 4 in gamma function, gamma n plus 1, then we get gamma 4 plus 1 equal to 5, gamma 5. So here gamma n plus 1 can be written as n factorial. So this one, gamma 5, can be written as 4 factorial. 4 factorial is nothing but 4 into 3 into 2 into 1. We get the answer 24. The same things using the Python program, we find the answer. From SymPy import. So here if you put a star, we need not write the gamma function, otherwise import we must write gamma. So what are the variables we are using that should be entered? X equal to, we are using only one symbol x in single quotation. Now we are finding the answer. So we are evaluating the integral. So e, otherwise we can give I integral. So here we type integrate, open bracket. So we write the question. So here integral 0 to infinity e power minus x into x power 4 into dx. So we type as it is, integrate the function x power e power minus x is there. So e exponential of minus x, it is multiple with x power 4. Then the limit is varies from x is varies from 0 to float infinity. Now we check the answer. So it is nothing but a print using gamma function we obtained the answer. So that answer is E. So we check the answer. So here we must put comma. So here infinity is not defined is there. So we float, we give it in terms of single quotation. Now we check. So here we are getting the answer using gamma function. We obtained the integral as 24. So as we have discussed here, see, by using the definition we are getting gamma n plus 1 equal to gamma 5. Gamma 5 can be written as 4 factorial. We are getting 24. So here we have done using Python programming to find out the answer. See, integral 0 to infinity e power minus x into x power 4 into dt. Using the Python program, we call the function gamma. So here we are doing the integration. So we call header file simpy import star. So here n is 4. So g is nothing but we are using the gamma function, gamma of n. So here we know the value of n equal to 4. We can give, otherwise we can give the input n equal to float. We can give integer also. Sometimes n is decimal places or fractions, so then we must give float input in single quotation. We enter the values of n, g equal to gamma of n. We check the answer, print using gamma function. We obtained. So what is the answer? We write it here. G is the output, n is 5. We are getting the answer 24. Beta of m comma n. This one is modified one in 2 times integral 0 to pi by 2 sine power 2m minus 1 into theta into cos power 2n minus 1 theta into d theta. Here m and n are greater than 0. And we have the formula relation between beta and gamma function. Beta of m comma n, we can write it as gamma m into gamma n dividing by gamma m plus n. So here we discuss the problem, and here we must know that gamma n plus 1 we can write it as n factorial if n is the integer. Suppose n is the fractional number, then we can write gamma n plus 1 equal to n into gamma n. So even if you modify this one, we are getting the n factorial. This one is used to modify further. Gamma n can be written as gamma n plus 1 dividing by n. So this will be helpful to find out the answer. Evaluate. Evaluate integral 0 to pi by 2 sine power 5 theta into cos power 3 theta into d theta. So here we refer with a definition. Beta of m comma n is there. Here 2 times are there. Here we do not have 2. So here while writing this one, we must modify and we must write it as 1 by 2 of beta. M and N we must write. Here we compare the statement definition, sine power 2m minus 1. So power 2m minus 1 is there, it is equal to 5. So here we modify this one, 2m equal to 5 plus 1 6, m can be written as 3. Similarly we compare the cos power, 2n minus 1 is 3, 2n equal to 4, n equal to 2. So 4 by 2 is 2. Now so here we write it 1 by 2 of beta of m is 3, n is 2. Now we use the relation between the beta gamma function to find out the answer. M is 3, n is 2. So here 1 by 2 of beta of 3 comma 2, we write it as 1 by 2 times gamma m is 3 into gamma n is 2 dividing by gamma m plus n is 3 plus 2. So we can write it this as 1 by 2 into gamma 3 is nothing but 3 factorial, 2 factorial, gamma 2 is nothing but 1 factorial dividing by gamma 3 plus 2 is gamma 5. So here we simplify this one, 1 by 2 into 2 factorial is 2 into 1 factorial is 1 dividing by gamma 5. Gamma 5 is nothing but 4 factorial. 4 factorial can be written as 24. So here we can cancel these two. We must get the answer 1 by 24 if we use the Python programming. We check whether we get the same answer. So here from SymPy import. So we are using the variable. So here we are evaluating integral (0 to pi by 2) for the function sine power 5t into cos power 3t into dt using beta function. So here from SymPy import, we put the star instead of calling the function beta and gamma function. We check whether we get the output. So here we give the input of m and n. So here by using the above one, we can write m equal to 3 and n equal to 2. So we are using this one here. Here m equal to float. Sometime instead of integer we may get the m as a float also. So here we float, we give the input, that is nothing but in single quotation m. Simply we give m, copy, paste, we replace m and m as n, then beta is nothing but half of the values are there. So here we can see we have written, we do not have 2 here, so we are using 1 by 2 here. So here we write it as 1 by 2 is nothing but 0.5 times beta of m comma n. So we get the output print beta. M is not defined, so here we give the value of that one in quotation. Similarly here also so here beta of 0.5 equal to beta into beta of m comma n. So we must get the answer. So here before that we must enter the value. We are entering the values. M is 3, n is 2, then we are getting the answer 0.041. So here we check the values. 1 dividing by 24. Here I equal to print I. So here we can check. See, I got the answer while solving the problem, 1 dividing by 24. But while doing the Python programming, we are not getting that answer exactly 1 by 24. Instead of that one, after simplifying, we are getting the answer 0.0416. It is nothing but I is 1 by 24. If we take the print, we are getting this answer. It is nothing but same. So here, instead of getting all the decimal values, if we want to reduce, then we must give the value in a single quotation, beta value. So we give it as 1.3 per floating, so percentage, then quotation. Now we give percentage beta. Now we check the answer. We must get the answer in terms of 3 decimal place. Now you can see we are having the answer 0.04. Here beta value is 0.042.